Let me repeat once again. Optimization theory is the discussion. Today's topic, optimization theory. Optimization theory refers either maximization of a function or minimization of a function. Either maximization of a function or minimization of a function. So you need to check what the objective function is. If the objective function involves the constants, then constant objective function. If no constants, then unconstant objective function. So optimization, after determining the objective function, whether that has to be maximized or that has to be minimized, you have to determine. Because being a manager, you have derived that function, objective function. That objective function, you will determine whether that is a profit function, cost function, total revenue function, sales function, whatever the function is, what is the nature of the function. If you find those functions has to be maximized, then optimization will refer to the maximization of a function. If you find the objective function is a cost function, then you know the function has to be minimized. So in that case, objective function, optimization technique or optimization refers to the minimization of a function. After that, you need to look to the objective function. What the objective function, whether that objective function is constant objective function or unconstant objective function. If you find that objective function does not include any constant, then that is treated as unconstant objective function, where there is no constants. And if you find the objective function includes the one constant or several constants, then there are two methods to solve. One is substitution method, another is Lagrangian multiplier method. Because that objective function is the constant objective function, so constant optimization technique has to be followed and has to be solved either by substitution method or by Lagrangian method. So that will complete this chapter of theory of optimization. So if the given function, in the given function there is no constant, so no constants are there, so unconstant problem. Here you will apply first order condition and second order condition. Here also first order, second order will be there. Simply after deriving the objective function, then first order condition will be equal to 0, and the second order condition, will be either less than 0 or greater than 0. Less than 0 or greater than 0. Less than 0 for maximization of a function, and for minimization of a function, this will be greater than 0. Less than 0 and greater than 0. Greater than 0. You know. So now I shall be showing you one mathematical sum, so that at least unconstants will be clear to you. Then this part next class I shall be explaining. So this you know, you have already studied in profit maximization. Same thing I shall be teaching you now, so that this will be a type of revision, as well as you will be able to understand clearly what the unconstant problem is, what the constant problems are. Shall I remove the board now? Please erase the board. Shall I clean it?
Okay, sir.
So unconstant optimization, unconstant problem. Unconstant. Constant. Unconstant objective function. Demand function P equal to units price 1000 minus 10Q. 1000 minus 10Q. Now, in this function, this is a given demand function. So you are, suppose being a manager, you want to maximize the total revenue or total sales, as Baumol says. You want to maximize total revenue. So from here, you will calculate first total revenue. What is the definition? How will you calculate total revenue? Total revenue equal to P into Q. So 1000 minus 8 Q into Q. You get 1000 Q minus 10 Q square. Minus 10 Q square. So this is your total revenue. Since there is no other restrictions, no other constants are given in this problem, so it becomes unconstant problem. It becomes unconstant problem. Unconstant problem. So here you will be, since it's a revenue function, you will maximize this objective function. This is the objective function PR equal to 1000 Q minus 10 Q square. 10 Q square. So you will maximize this total revenue function. So for maximization of a function, you have to maximize. For maximization of a function, maximization of PR function, total revenue function, first order condition, delta PR by delta Q equal to 0. You know, so then, or delta